Live. All right, here we are. Welcome and thanks for tuning in to today's AllocNow webinar on the TfS PCF Guideline and how to implement it at scale. My name is Daniel Bochnicek. I am one of the 4 co-founders of AllocNow, and I also serve the company as the CEO. And today it is my pleasure to guide you through this webinar. First things first, we would like to start with some housekeeping. Given the high number of participants, you are all muted and your cameras are disabled. Otherwise, we may have ended up in chaos. However, we do welcome your questions and your reactions. So please use the questions icon on the bottom right part of your screen to pose your questions. And we will try to best to answer as many as possible towards the end of the session. And thirdly, this webinar is being recorded. And we're happy to share the link after the session on request. So if you would like to have access to this webinar, feel free to approach us. We will make sure to make it accessible. Now, for the following about 45 to 60 minutes, we have the following agenda for you. First, I will start with some opening remarks on why we think this is a very important topic on the relevance, and also to make sure that we have a common understanding or a baseline when talking about the TfS PCF guideline. Secondly, we're very happy to welcome Alessandro Pistillo joining us today from BASF, and Alessandro is also the co-chair of the GHG Scope 3 emissions workstream within TfS, and we have the opportunity to ask some of our questions, and yeah, we're really looking forward to the discussion with him. Thirdly, my colleague and head of product at AllocNow, Nico Lauter, will give us some insights on how we can use the TfS guideline to actually automate lifecycle assessments with the software that we provide, the AllocNow product sustainability platform. And last but not least, we're happy to take your questions and we'll do our best to answer as many as possible in this session. That said, let's get started. Now, the chemical industry certainly has a major role to play when it comes down to driving down emissions. And you may all know the famous 95+% of consumables being dependent on the supply of upstream chemicals. I think this number really underpins the potential of the industry to enable and to contribute towards a sustainable consumption. However, we all know the size of the potential, the great potential, but we also know how difficult of a task this is. Just because of the nature of the industry, its heavy reliance on fossil feedstock, and of course its energy intensity, resulting in very high upstream, but also end-of-life emissions. However, the good news, and I'm very sure some of the participants here may recognize some of the numbers on these slides, the good news is that the industry is moving, and the industry is committing to very, very ambitious targets regarding the reduction of carbon emissions. And it's not just the commitment towards targets, but it's also about taking action, by deploying new technologies, by making investments. Just to give a few examples, in non-fossil electrification, in the use of biogenic or renewable materials, or the deployment of CCU technology. So a lot is going on and a lot is happening. These public commitments and these very strong commitments, however, also lead to the fact, and that is very natural, that people expect to see that in the product, right? It's downstream customers, B2C and B2B, who expect to see an effect of those activities and those goals being named, and to see that effect as an improvement in the emissions profiles in the products over time, and their demand for transparency on what they actually buy. However, it's not just external customers wanting this transparency, it's of course also internal stakeholders within the company providing or having the need for such a transparency to take relevant action, right? And just to name a few, it's of course in procurement, it's in research and development, maybe it's even in product management and marketing. So many functions require the information, on a very granular level to take action and to respond to those KPIs. And that poses a challenge because we see that the characteristics on sustainability, or the information on sustainability characteristics of a product, are actually becoming a basis for actual decision making, for strategic decision making, and for operational decision making. And that leads to the fact that companies need to provide this information on a way higher specificity, on a way higher frequency, and also on a way higher comparability if the stakeholders, internal and external, aim to make decisions. And that is a challenge, especially if you look at the way that those data is generated today, based on often manual lifecycle assessments, if at all. It's very cumbersome and very effort intensive to provide this information. And not only is it cumbersome and effort intensive, we all know, or at least those of you who have read the relevant norms and guidelines, we all know how difficult it is to actually model in a consistent and in a coherent manner, even within your internal product portfolio. And I think this is really a step change that TfS has now provided with the guideline that has been published now in the past few days, providing a step-by-step guidance on how to calculate product carbon footprints. It's of course based on ISO norms, ISO 14040, 14044, 14067, the Greenhouse Gas Protocol, and some sector-specific guidance from the World Business Council for Sustainable Development. And it has been developed by 37 chemical companies in a consensus process. And that is a very, very interesting approach, I think, because it really shows that the industry is behind this and the industry is trying to really make a step ahead. For those of you who have not received it yet or not read it, it is available open source. I've noted the URL below the picture, so tfs-initiative.com. If you go to this website, you'll find it there. It's a 50-page, approximately 50-plus page document, and it's certainly worth to read. So this is why this document and why this approach, from our point of view, is really highly, highly relevant, not for the industry, but really for enabling sustainable consumption, as the information being provided upstream is so relevant for all the downstreams too. But before we continue in the discussion, let's maybe look at a few aspects of this guideline. Let's look into the details and the content of the guideline before we then have a discussion with Alessandro. And you may excuse me that I'm not going to be able to summarize all the 55 pages in very, very detail. I'll focus on 4 important topics from our point of view. That is firstly the scope of the guidance and the scope of the methodology, so what is actually covered. That is secondly the data requirements. That is thirdly something very specific to the chemical industry, which is addressed in this guidance. That is the handling of multi-output processes and multi-output production. And last but not least, we'll also look at 2 topics which are not fully addressed yet in this guideline, where the guideline also says that further refinement is necessary going forward. So that's the 4 topics that we'll cover in the few next minutes. Now, first of all, what is the scope of the guideline? What is the scope of the product carbon footprint calculation prescribed in this guideline? It covers a cradle to gate scope, which means basically from the extraction of material, considering all the activities until the product leaves the gate of a chemical company. And the declared unit is not comparable to a functional unit, which is this typical item you would address in a life cycle assessment. The declared unit is really 1 kilogram of product unpacked at the factory gate. And what needs to be considered within this scope is, of course, all the direct emissions arising from all the processes and activities from the cradle, from material extraction to leaving the company gate. Secondly, it's all the emissions from the generation of purchased energy in utilities. In chemicals, of course, it's not only power, it's also steam and other utilities. And thirdly, is also the emissions of all raw materials that are consumed in the different processes. Right? Now, you may ask, why is it a cradle to gate scope only? Well, the reason is quite simple, because that's also what the norms state. The use profile of chemicals is so heterogeneous, right? So things can go into pharma, food, automotive, packaging, you name it, and it's simply impossible to really look at a cradle to grave scope, as what happens in the use phase, also in the end of life phase, simply not very easy to determine as a chemical producer being so far upstream in this value chain. So that's the scope that is covered by this by this guidance, and this is what is prescribed to be calculated by suppliers and of course chemical companies themselves. The second very interesting aspect that we are often also tasked with in discussion with our clients is the question on data requirements. And I think that is something that the guideline also, compared to the existing ISO norms, really stresses a lot and underpins a lot, because it endorses a bottom-up approach based on actual activity data, and that is very interesting, right? So actual activity data, which are in best case measured and recorded live from your operations, from your productions, on all assets that are under your control, right? So that's it. And of course, there's many things to talk about, but if I were to summarize this statement in three keywords, it's three things. So first of all, it's actual data. So looking at the actual in and outflows of the production, looking at the actual consumption mixes of production. That's very interesting and very important to state. Secondly, it's the aspect of being site-specific. That means it's really about calculating product carbon footprints or environmental emissions, environmental footprints for a product being produced at a specific site. So we don't look at global averages or anything like that. It's really very specific, very granular to be calculated. And the third aspect is the prerequisite to be representative. And this translates into the requirement to use data which cover at least a 12-month time horizon to prevent cherry picking and using a specific months where your operations weren't redefined, so at least 12 months, up to a maximum of 36 months to level out potential fluctuation. And the guidance is also to use the most recent reporting period. So try to be as close as the date we're in today, and take data of at least 12 months to a maximum of 36 month horizon to level out differences in production. And those three aspects apply to all data where we can measure activity data. And that is, of course, material inputs to a process, energy inputs to a process, direct emissions from a process, the outputs can be multiple, and waste. And on top of that, in best case, we also have primary-based or activity data-based emissions factors. For example, when you run a power plant on site, this is a case where you can very well define specific, site-specific and actual emissions factors too. I'm not going to go into the details on cutoffs. Of course, cutoffs may be applied for practical reasons, always given that the environmental significance should be reflected. So you shouldn't cut off things which have a low quantity share, for example, but a high impact. So you need to be careful with this. But in general, the idea is to not apply cutoffs, as looking at the actual and activity data-based approach. The goal is really to model everything that you have. So that's mainly focusing on the activity data side. The second question on data we often discuss is the question on the use of emissions factors. And similar to the activity data, the rule also applies to go for primary data over secondary data over proxies or estimates. And there's a clear hierarchy on how to proceed. So firstly, as discussed before, wherever you have data available, actual and site-specific and representative data, use those also for the emissions factors. And if you don't have it in-house, as it's not under control, ask your suppliers to do that. And I think this is also one of the intentions of this methodology, to give your suppliers guidance on how to actually calculate those primary emissions factors. So very important. However, in reality, of course, there are many cases, especially when we look at the raw material emissions, so the 3.1, scope 3.1 emissions in GHG speak. We will heavily rely still on secondary databases. And the guidance gives a clear hierarchy there too. Try to be as specific regarding the region and the technology as possible, and then take the most appropriate proxy, right? So there's always ways to go downwards, but try to be as close to reality as possible. That's a very, very simple statement that you can memorize. And something new that this guidance actually came up with is the primary data share, right? So it's actually required to state in the reports and in your final results to what extent you actually base the calculation based on primary data. And that does not only apply to activity data, but also for the emissions factors. And regarding the secondary data, you need to make sure to also report and to document the sources of the secondary data. And the report also gives some recommendation on high quality databases such as Carbon Mines or Econvent, for example, to use for your calculation. So very hands-on and very clear guidance on which data to use. Try to be as close as possible to reality. Take whatever is measured. It's always better than secondary data. And then, of course, work with secondary data to fill gaps. And last but not least, use proxies and estimate if you need to. As long as you can make it transparent, that is very much okay. Now, that was the data part. I said there's one very specific aspect in this guidance really dedicated to the chemical industry, as I think it's one of the industries where this is probably, there are certainly other industries where it's also relevant, but it's highly relevant in this industry, and that is the challenge of handling multi-output processes. And of course, the general ISO norms give guidance on this, how to handle it. But I think the TfS methodology here really made it way more concrete and gave a very clear decision tree on how to go forth when you face these kinds of processes. So when a multi-output situation cannot be avoided, and this is of course always the first case you should look for to avoid to model it as an allocation case, the rule says basically, or asks a couple of simple questions. First of all, if there is an accepted product category rule, and product category rules accepted by TfS are also clearly defined for steam cracker, for chlorine, for C12, C14, and for isocyanates. If a product category rule such as this is available, use this product category rule. If not, there's one little thing you should consider. If hydrogen is one of the co-products, go for heating value, either lower or higher. As long as you're consistent, it's fine. And then last but not least, if this is not the case, you need to validate the ratio between, or the ratio of the economic value of the co-products. And if it's larger than 5, so if one product is 5 times more valuable than the other, go for the economic allocation. Reason being that obviously this is the most, let's say, the dominant driver of that production. So this is where the allocation should go to. And if it's below 5 or less than 5, go for a mass-based allocation. So take the actual quantities, the mass of the multi-output processes as a proxy for allocating. Now you can see here on the number of footnotes that I've obviously simplified this a little. There's of course some additional minor rules and edge cases to consider, but in a nutshell, this is what you actually would look for in the multi-output situation. Now, allow me one remark, as this is really very important, as especially when we talk about using a data-driven approach to modeling this. This decision tree is not only very important in terms of clarifying things, it's also very important to understand which data and how to use, which data to use and how to use them. And maybe one remark out of practice that this is really something to really look out for when you consider using data which are typically used in your cost calculation for modeling lifecycle assessments. That's where things sometimes break, because those rules are typically not applied in your standard reporting or accounting tools. Very important to note that. So if you want to be consistent, you need to make sure that your multi-output processes actually comply. Now, last slide on the methodology. We've seen what it actually does. It makes it very, very concrete. It breaks down, let's say, pretty abstract norms into practice for the chemical industry. But in few cases, the guideline also leaves some options, and it clearly outlines, and I think that's very valuable, outlines the need for further refinement. And I would like to pick out two, just exemplary. There are a few others, but the first one is the waste treatment aspect and the material recycling aspect, where obviously the guideline was not able, or let's say the consensus within the group of TfS company wasn't wasn't found. And there are several approaches. So you have multiple options on how to model waste treatment and material recycling. And of course, they have pros and cons, which are also thoroughly discussed within the report. You have the choice to choose, but you need to make it transparent and you need to document it. And another second important topic, which is not fully reflected in this report yet, also given the case, the fact that this would, of course, probably take another 50 pages, is the topic of mass balancing, which is increasingly important in the industry, but unfortunately not very easy to align with common lifecycle assessment norms. So that's something to be worked on in future. And this is something which is not fully reflected in the report yet. So to summarize, or in a nutshell, what is the report? First of all, I think the good news is it's really in alignment with common norms and guidelines. So it really takes reference to all the relevant norms that you need to be aware of and you need to watch out for. It's very valuable because it narrows down options and gives hands-on guidance for LCA practitioners. And I think personally, this is a very interesting and important aspect. It acknowledges the fact that we're at a starting point of basically professionalizing or further driving the sustainability reporting, and it acknowledges the fact for continuous further development, not only taking the internal view, but also taking external references of things that are happening in Catena X and other areas which are relevant to the industry. So this, I think, is very important. That said, this is an overview, and I think, now I hope everybody has had a quite good picture of what actually happens in those 50 pages. And as I said, I'm very happy to welcome now Alessandro Castillo, who is available for an interview. Alessandro is, as I said, a co-chair of the TfS GHG3 emissions workstream. He's also with BASF. And maybe, Alessandro, to get us started, as you've been personally involved in the development of this guideline, how would you describe the motivation and the objective of the guideline, let's say from a more of a strategic point of view, that TfS embarked on?
Sure, Daniel. First of all, have a good day to everybody, and thank you for having me here. Well, I would say that the main reason for going down this route from TfS side to get a feasibility side and developing this guideline is fundamentally the recognition of the importance of Scope 3 for determining carbon footprint information, no matter if it's at corporate or a product level in the chemical industry. And then fundamentally, the necessity to have something specific, some more specific than a classical standard generic standard or guideline like the ISO standards or the GHG product protocol. So specificity, one, comparability by being more specific and more prescriptive, having a guideline which enables to have then a more apple-to-apple comparison between product carbon footprint. And last but not least, to have also an element of trust. Obviously, many companies have delved into this topic in recent years, or some companies since many, many years. So there are company standards out there, but it's of course much more valuable to have a guideline which is endorsed by a larger cross-section of the industry rather than something which is only endorsed or officially endorsed by one single company. Mm-hmm. So these are the main reasons to delve into this topic, and in that sense, I think this is quite trend-setting, since there's not so many other industries which have taken a route like this and achieved this milestone like the chemical industry. Mm-hmm. I would say that probably one of the reasons is also because the chemical industry is so far upstream to many other industry segments that in fact there is a high necessity to have standardization for this basic industry first before you get further downstream into very, very specific consumer items.
Mm-hmm. Yes, and of course also probably the fact that you are customers and suppliers at the same time also enforces this and drives this. Certainly a very remarkable process. And you talked about trust. And I said in the beginning, it's I think 37 companies actually developing this guideline together. So maybe elaborate a bit on the process of how did that actually work? I mean, was it 37 different versions that you've then tried to consolidate, or how did you go about it?
Well, obviously, there have been a number of companies which have nominated a specific person or multiple people even to collaborate in the editing of such a guideline. There have been numerous workshops in the work stream. Whatever was available to each and every of the company participating was brought onto the table. So you didn't start with 37 versions, but you started with something perhaps much more consolidated. But then there was a very strong participation from members, from various members. And last but not least, prior to publication, the draft has been also circulated to several dozens of testing companies, so companies who are not members, not yet members of Together for Sustainability. It's not a closed club. Any company meeting certain criteria can join anytime Together for Sustainability. And fundamentally, feedback has been collected from real suppliers, also non-TfS members, and this feedback has been incorporated into this document. Last but not least, it was important also to align. It has been important to align with other initiatives, and let me mention one: the PACT program of the World Business Council for Sustainable Development, which also aims at having some alignment or a high degree of alignment between different industries and different industry verticals. Therefore, having a strong connection with WBCSD was very important also in the development of such a guideline as well.
Mm-hmm. Right. Yeah. Very interesting process. Thanks for sharing this. Now, I know, and probably all of the participants, or most of the participants know that BASF has, of course, also provided a similar guidance a couple of months or even years before. So you've been very active in promoting the standardization of calculating product carbon footprints, and basically published the so-called SCOT methodology. So I assume that was certainly one of the inputs to this process. What really changed? So how would having something brought into this process, and what were the aspects that were that differ now, and where do you see, let's say, progress compared to the initial draft that you had internally?
Well, sure. Definitely, the BASF guideline for product carbon footprint determination has been provided as an input into this TfS guideline. That's for sure. I would say the differences between the TfS and the previously BASF available BASF guideline are not too great. To a larger extent, the major differences are in the reporting requirement. So which type of data, along with the product carbon footprint, are intended to be exchanged in the future between suppliers and buyers. This was something which was not addressed in the full detail at full scale in the previous BASF methodology, and that's a very much more detailed now in the TfS document. There has been some additions, like definitions like a primary data share KPI or data quality rating, data quality scoring. There are quite some pages dedicated to this. Technically, there have been also some adjustments in specific situations that we have in the chemical industry, like in the case of carbon capturing and use technology. There, the TfS suggests a specific approach, which is very specific now, the TfS guideline. So that's, you could say that those are the major deltas between the two. But with that being said, and I think it has been also communicated directly after the publication of TfS guideline by BASF. BASF is fully committed to this work and fully committed also to together for sustainability standardization efforts. And the BASF guideline will be brought to compliance, to full compliance to the TfS methodology in any case. So basically, there is no difference anymore right now from that angle.
I think it makes a lot of sense to also tackle the reporting issue now, since, I mean, this is obviously something that requires the consensus across multiple organizations, as you need to clarify the interfaces, right? So it's always two parties in reporting, one sender, one receiver. And yeah, that certainly makes a lot of sense, not technically, but content-wise. So I'm very happy to hear this. So if you look at the guidance as it is, you know, there are some hints in the text here and there on the further development, on the future. How do you see the future? What's going to happen in the next few months, in the next years to come? What do you think are the major influences and changes to be expected?
Well, first of all, I think we need to be mindful that the topic is still very fresh, right? There is still some aspects around product carbon footprint determination which still are not fully elaborated in this document, but in general in the industry. I mean, you mentioned already in one of your slides the topic of mass balancing, for example, which is chain of custody methodology, which is very central actually for the achievement of net zero for the industry overall. And this topic is handled already in the guideline, but not in full detail. And this, for example, will for sure be a further area of work of Together for Sustainability on this topic. There are some other aspects which will be surely subject to further discussions, even when we talk about reporting and the data exchange, data models, they could say. And with time, there will be more and more discussions between chemical industries and other industries, right? Or TfS and other organizations like mentioned World Business Council for Sustainable Development, or many others like Catena X in the automotive industry, and so on and so forth. And in the wake of such discussions and alignment, there could be adjustment in the reporting requirements as well. So it's not now a document fully cut in stone, but it provides already a step change in the availability of standards. But it will be definitely be further developed along the line of this discussion also with other industries in the next months or years to come. And last but not least, PCR, you mentioned PCR, product category rules. These are still relatively few. And with time, there will be more and more likely product category rules popping up for one or the other technologies. And this will be incorporated according to, of course, a governance process within the TfS document as they will appear.
Yeah, makes a lot of sense, and very good to hear that it's really a document which is supposed to be further developed over time. And yeah, so I think that's very relevant given the fact that we're probably all in the infancy of providing this information at scale. So last question maybe on let's say more taking the BASF view on the topic. So how do you personally, or not personally, but as BASF, of course, how do you go about implementation? What do you see as the next step, and what are the greatest challenges for you in implementing this guideline for BASF?
Well, I think we can say that there are a number of necessary steps for us, but I would say most likely for every company, since we all have similar challenges. Well, having a guideline is a fundamental ingredient to have a carbon footprint transparency, but still, with a guideline alone, you don't calculate product carbon footprint at scale. I mean, from BASF side, we are lucky to have already a fully productive tool to do so. That were known perhaps in the meantime, Scott's tool. Scott is capable to calculate according to TfS guideline already today, basically. So it's that will not be a major hurdle, but as an important step to have a full carbon accounting on a complex portfolio. The other step will be to now with the help of TfS will be much easier engage suppliers, no matter if big or small, to have clarity about how a product carbon footprint should be calculated, and then enhance the primary data share we were talking about, right? So the principle or the spirit behind the guideline is to have more and more primary data to populate basically the data pipeline. So engagement suppliers with engagement supplying programs will be fundamental, is already, but it will be further accelerated and helped by this development of TfS. Mm-hmm. And last but not least, TfS, and that's not BASF alone, but within TfS, there is currently a project to develop the data exchange platform to provide an additional tool to enhance product carbon footprint transparency in the value chains. So providing secure data exchange mechanisms so that companies can exchange product carbon footprint data in a standardized fashion and in an efficient fashion, not now having different type of requirements and reports from different companies, right? So that's certainly a key area of work for TfS, but also for BASF, of course, as part of TfS.
Yeah, and I think that's a shared problem or a shared objective, really, to increase the primary data share, right? So that's, I think, one of the headlines of the methodology is go for primary-based calculations. And that also requires, of course, to get primary data from the suppliers, which is a common challenge in the industry, and I think all companies are facing that. All right, so we've talked. Thank you, Alessandro. Thanks a lot for those insights, and yeah, you'll be ready for the Q&A later. So we've talked a lot about the guideline, about content, about goals, about some specifics. We also promised to take a look at how we can actually automate the calculation of LCA or the lifecycle assessments in compliance with this guideline. And therefore, I'll hand over to my colleague, Nico Lauter, Head of Product with AllocNow, to share a few insights on how you could do this using a software such as ours, the Product Sustainability Platform. So Nico, stage is yours.
Thank you, Daniel. As we already have some questions in the Q&A section, I'll try to rush through a bit so that we will have some time to also answer them. But as already introduced, we are now going to talk a little bit about implementing life cycle assessments at a company. And we could now go through all the single steps you need to run through to be in line in the end with the TfS guideline. But what I would rather like to focus on today is to give you a first idea on how to automate life cycle assessments at a company using a suitable software solution like our product sustainability platform. because in the end, and this is at least what we truly believe, this is key to serve the continuously increasing demand for product-specific sustainability data. And to do so, I will, on the one hand, share with you our modeling approach, and on the other hand, I will also provide you some insights into our, well, let's call it key modeling principles that we follow. But first of all, before we jump into the really content-heavy part, let us take one step back and align on our understanding on what we actually mean when we're talking about automating life cycle assessments. And here I would like to point out two major aspects. First, because we are talking a lot about climate change, we're talking a lot about calculating PCFs. For us, automating life cycle assessment is far more, because it should always include and always consider, although it's probably not the point you're all starting with, but it should always consider that there are also other impact categories like eutrophication, acidification, resource depletion, and so on, that are important to measure, that are important to calculate, because only the full picture gives you all the transparency you need to have the environmental impacts of your products. Second, we understand automation as creating transparency across the entire product portfolio. No matter how many products are included, it's always about the entire product portfolio. And to kind of detach the overall effort you have from the overall number of products you have, because this is most likely the major difference between automating lifecycle assessment and still running single LCAs. And in a nutshell, this is what we mean when we're talking about automating LCAs. It's about having the environmental impact of all your products available. That's it. That's our goal. Now, how do we achieve this? Or let me phrase that kind of differently. How is it possible that we are able to calculate the environmental impacts across your entire product portfolio at once? And the answer to that is quite, or seems to be quite simple. It's just by building a comprehensive emissions flow model of your entire company based on systems data. And such a model typically comprises of two different worlds, two different dimensions that are usually not brought together in a company. On the one hand, we have the production network that comprises of all your raw materials, all your intermediates, all sales products, but also all your transfers, all your processes, and all the connections between them. This production network serves as a kind of basis for our calculation. And we built this production network model based on actual material movements from your ERP data. So there is no manual modeling anymore. There are no idealized value chains anymore. It's all about actual material movements across a representative time horizon. Daniel already gave you one remark, and it's worth to stress that again, because this is a frequently asked question, and probably some people joined later. When you tend to rely on your cost calculation networks, be aware of that these may not be compliant to the TfS guideline, because, or to the ISO norms as well, because they are, or they may treat, at least as an example, multi-output protection differently than it is required in the TfS guideline. So always be aware of that the production networks in your cost calculation system, that the consolidation there may not suit the requirements given out by TfS. On the other hand, there is the kind of emissions profile of a company, which includes all the direct and indirect emissions. And while the production network data is quite standardized, many companies rely on SAP, we see a wide range of different reporting tools, reporting mechanisms regarding the emissions tracking. So we have a lot of company-specific emission sources there. But good news, usually a lot of data is already available regarding energy consumptions, regarding direct emissions, waste and wastewater quantities. All this information are usually there because they're already used for other reporting purposes. So these are the good news. And once we've identified all the relevant data sources, all the data sources you need to model the production network and to get a full picture on the emissions and to transform the emissions, we built, and this is the most challenging part, this is the most effort-intensive part, we built a company-specific data pipeline that allows to automatically extract and join all this data, which results in the end in what I've already said, in a comprehensive emissions flow model across the entire company, which allows us then to calculate for each and every product within this network these specific environmental impacts. To build such a model, we rely on, and we try to break it down a bit. Of course, there's more behind it, but we try to break it down on 4 key modeling principles. First, primary data first. And this should not surprise you, because Daniel already stressed that. Alessandro also already mentioned that the models you shall build to be in line with the TfS guideline rely wherever possible on primary data. Of course, there may be emissions you are not aware of, you won't have primary data for, especially when it comes to scope 3.1 emissions, so your upstream emissions that were caused by your supplier, then it's totally fine. And there are some pretty good database providers out in the market that help you with secondary data in this regard. But whenever possible, and this is usually possible when it comes to emissions you caused and emissions more or less in your responsibility, it is possible to run primary-based calculation. And this is also what we fully rely on, especially to be compliant to the TfS guideline. The second modeling principle deals with the level of granularity we are calculating on. We try to be as granular as possible, because this also provides some insights, especially for internal stakeholders, that can trigger meaningful actions. In our case, it's always a material plant combination, what means that we're calculating the environmental impact of a product depending on where it was produced, so that you can also see and have full transparency on whether there are differences between different or various production regions, and then you can further investigate why this is the case. This really granular level may not be the level you want to report values on. And this is also something you always should keep in mind, and you always should consider when setting up such a model, to allow some kind of aggregating these values, to allow some kind of aggregation functionality. We usually leverage the material hierarchy information from master data to allow our users to build kind of material groups and aggregate values they can then communicate to the market. Because what you definitely do not want to trigger is some cherry picking, that your customers are selecting specific products from specific sites, because this would suit their own sustainability targets. The third modeling principle is more or less something to keep in mind, to always keep in mind, and it's about avoiding double counting. When we shortly touch the emissions part of our modeling approach, I already mentioned that there might be some customer-specific systems, and we usually combine many different data sources there. And there it can definitely happen that you count the same emissions twice, which will lead to the fact that you're calculating the environmental impact of your products worse than it actually is. So always make sure that emissions you are responsible for that occur, that they're only counted once. Otherwise, your products would look worse than they actually are, and we definitely don't want that. Last but not least, the fourth modeling principle, a pretty important one for us, and that's it to make LCA in future a cross-functional topic. Of course, you will definitely need your LCA experts, because they will have the full transparency on all the emissions-related topics. But we also saw that regarding the production network modeling, there are ERP systems involved. So in future, you will definitely also need experts regarding material movements, regarding master data. You will probably need controllers. So your team, if you would run a project to automate lifecycle assessments, your team should be larger than only limited to a few LCA experts. You also need some other expertise, and therefore we always suggest to have a cross-functional team. And I'm looking a bit onto the time. I definitely rushed through that. We didn't touch any topics in detail. I hope I'm not leaving you with more questions than we actually started. But that was our really short journey to the more or less world of automating lifecycle assessment, of calculating environmental impacts at scale. And if there are still open questions, I would just highly invite you to ask them in the Q&A section, or also feel free to reach out to us. We're always happy to share our view on the topic of automation, and we're also happy to share our idea of a potential solution, how it may look like. Thank you very much. And with that, I will hand over to you, Daniel.
Daniel, you are muted, I think.
Sorry, thank you very much, Alessandro. So I said thank you very much, Nico, first of all. And I also said we have a bunch of questions in the Q&A section. I'm not sure if we'll be able to answer all of them. Likely not within the 10 remaining minutes, but we'll make sure to follow up if we can afterwards. So maybe to get us started, let me just look at one. Maybe one of the participants asked, maybe that's a question to Alessandro. As you've addressed the necessity to also engage with your suppliers and to gather data from them, how to create a platform to easily share data if everybody is depending in some form on another. We have to start somewhere, so I guess the participant is from the industry, and as everybody depends on secondary data and you want to build more accurate models, you need to get towards primary emissions factors. So, and I know you've addressed a bit the topic or the process within TfS. Maybe can you say a few words more on this process?
Yeah, first of all, perhaps just not to keeping the picture, the secondary data. Of course, the secondary data are crucial today and will stay super important in the next years to come as well. So it's not that we will always have only primary data. Perhaps in a far future, yes, but not in a long transition period. So having secondary data also which are consistent to a certain methodology will also be important. That's for sure. Now, this efficient exchange mechanism and this emergence of or necessity of a data exchange platform like the one that I was mentioning TfS is working on right now, will be exactly going to this direction, how to facilitate the exchange of information and how to make a product carbon footprint available and shareable in an easier way. With that being said, the sharing will be most likely will not be a public sharing. So it's not that a product carbon footprint is published and everybody can use it. At least this, I foresee this will not be the beginning of the journey, and therefore this secure transfer and standardized transfer mechanism of PCFs will be an important step in this direction.
Yeah, thank you very much. Right, so let me just see if there's something attached to this. Not really. So maybe as a new aspect, so maybe a question towards your direction, Nico. One participant asked how long the process takes on average to build such a model that you've outlined and to implement an LCA tool to automate LCA. What's your experience?
Yeah, I was already phrasing my answer, but yeah, probably worth to share that with all participants. This highly depends on your systems, but we always commit on implementing this solution on a global scope. So for your entire company, that it will only take below 1 year To give you a actual number, it's always hard to sell. Like I said, it highly depends, but it will take less than a year for us to implement it at your company, so that you also have then all the environmental impacts of your products available.
Thanks. Another question we received, maybe towards Alessandro again, are there organizations certifying PCFs which are calculated based on the TfS methodology?
Well, we should keep in mind that the methodology has just been published, so that's really very, very fresh. But for sure, it will be probably a business for some certification company to do exactly that. Indeed, Together for Sustainability is also looking into having certification of compliance of the guidelines with, for example, existing standards like ISO and GHG product protocol. This is certainly an area of exploration, how to make the validation and the validation of the result and the certification of the result also easier and automate and have it automated or more automated than today. So this is definitely an area of work, and the answer is clearly yes. Yes, there will be still the necessity to perhaps on a spot basis to assess that the product carbon footprint has been calculated exactly according to the guideline or not.
And I think maybe to add on this, the guideline explicitly states that it's a prerequisite to have at least some form of verification. It can be done internally, but this would need to be stated. And the recommendation is to have a third-party auditor actually to review the results and to ensure that it is compliant with TfS. And as also the methodology itself is based on, let's say, the mother of all norms, right? So in ISO terms, so 14044, this is probably, it's a high likelihood that the typical auditors and third-party reviewers are or will be able to review existing results also against the TfS standard, very much in line with what's out there on the market anyway. So I would confirm that. Right. Okay. Maybe one more question as we're about to close this session. Where is it? Right. So somebody asked, maybe from a distributor's view, probably not a producer, but a distributor, how do you see the process of PCF data sharing after the gate, in particular the contribution of distributors? And knowing that the industry, of course, is very dispersed, and industry distributors play a significant role. How do you see that, Alessandro? How do you integrate distributors into this process, and what do you think they have a role to play?
Yeah, first of all, there are distributors, members of Together for Sustainability. Top of my mind, there is one, Brenntag, for example. So the perspective of a distribution has been definitely taken into account in developing the guideline. I would say from a PCF value perspective, the impact of distribution is, of course, very, very little, because the amount of PCF that the distributor adds on top of the embodied emissions in the product is coming just from the logistics to a large extent. So very, very minimal. In that sense, the distributor will be engaged in the exchange of a product carbon footprint with the principal company and then with the respective customer. I don't say that it's fully the process is fully defined with that respect. It's something that we definitely needs to be worked out in greater detail, but definitely the impact on the value is almost negligible, I could say.
I mean, in terms of impact on the PCF, certainly. I think in terms of strategic, let's let's say, establishment of the guideline, I do see some role to play for distributors, given that they kind of bundle all of the SME companies, which, I mean, the industry is really dispersed. There's few large ones, and there's many, let's say, smaller organizations, and which heavily rely also on distributors. So they could have a very interesting role to play also in standardizing PCF calculation in that market segment, which is not the large players like the BASFs and the like. So I do see some role to play for distributors as well, if they start to engage and also push for the carbon footprints or any environmental characteristics being supplied in compliance with the TfS guidelines. So certainly a very interesting aspect too. Okay, so with respect to time, it's 4 o'clock, everything that remains for me is basically to close the session with an invitation to contact us if you like afterwards. So our contact details are in the slide. Just check out AllocNow.com, or feel free to write an email to hello@allocnow.com. You can also do this if you want to approach Alessandro. We'll make sure to forward. I thank you all for your contributions, and I thank you all for the questions that we've received. We'll try to make sure to answer them afterwards, and we may contact you individually if they are too complex to answer in front of such a large audience. So once again, thank you very much. Special thanks, of course, to Nico. Very special thanks goes out to Alessandro for your contribution and your participation. Thank you very much, and I wish you all a very nice remaining afternoon or day wherever you are in the world. Thank you. Bye-bye.
Thank you very much. Bye-bye.
Thank you very much. Bye-bye.